Hello everyone, my name is Pranav Teja. I welcome you all to my concept video presentation. This is a subject of C language, and the topic that I am going to say in this concept video is the topic that I selected was define pointers. So first of all, let me introduce myself. I am Pranav Teja. I am from branch CSC AIML, subject C programming, topic define pointers. We are going to go through basic concepts of the pointer. Define pointers. Pointers in C explained. They are not as difficult as you think. Generally, people think pointers is in the C language is one of the difficult topics. People generally avoid learning this topic, but this is the most important topic in the C, and which is not at all difficulty if we understand it thoroughly. So let's see. Points are arguably the most difficult feature of C to understand, but they are one of the features which make C an excellent language. In this article, we will go from the very basics of pointers to their usage with arrays, functions, and structure. So relax, grab a coffee, and get ready to learn all about pointers. Definition, notation, types, and arithmetic. What exactly are pointers? Before we get to the definition of pointers, let us understand what happens when we write the following code. Int digit is equals to 42. Here we are just assigning value 42 for an integer digit. Here int here is a data type. Digit is a variable. Is equals to 42 is a value that is assigned to this variable. Just a simple assignment. A block of memory is reserved by the compiler to hold an integer value. The name of this block is digit, and the value stored in this block is 42. Now to remember the block, it is assigned with an address or a location number, say 24650. The value of the location number is not important for us, as it is a random value, but we can access this address using the ampersand or address of operator. Here let us see what is the code written down here. Printf, the address of digit is equals to percentile d ampersand digit. Basically it prints the address of digit is equals to 24650. Basically it prints the address of the digit that we have seen in the previous slide. Looking at the value of the variable digit from its address using another operator stub. Definition and notation. The address of a variable can be stored in another variable known as a pointer variable. The syntax for storing a variable's address to a pointer is data type star pointer variable equals to ampersand variable name. For our digit variable, this can be written like this: int star address of digit is equals to ampersand digit. Or like this. int star address of digit semicolon address of digit is equals to and percent digit 42 address is 24650 address of digit is 24650 another random address 42357 address of digit is this is there in the address 42357 the value is 24650 in here or the digit 42 this is the address for this digit this is the address this can be read as a pointer to integer address of digit stores the address of and percent digit variable. Few points to understand. Data type. We need to tell the computer what the data type of the variable is whose address we are going to store. Here integer was the data type of digit. It does not mean that address of digit will store a value of type int. An integer pointer like address of digit can only store the address of variables of integer type. Int variable 1 semicolon int variable 2 semicolon char variable 3 semicolon int star address of variables. Star star is a pointer variable is a special variable in the sense that it is used to store an address of another variable. To differentiate it from other variables that do not store an address, we use star as symbol in the declaration. Here we can assign the address of variable 1 and variable 2 to the integer pointer address of variables, but not to variable 3 since it is of type char. We will need a character pointer variable to store its address. We can use our address of digit pointer variable to print the address and the value of digit as below. Here, let us look at this code. Printf. The address of digit is equals to d, comma address of digit. It prints star prints the nothing. It prints just the address of digit is equals to 24650. Now here this is printf. The value of digit is equals to percently star address of digit. Star address of digit is the value of the address that is of that address. Value of the variable that is there in that address. Here, star address of digit can be read as the value at the address stored in address of digit. Notice we use %d as the format specifier for address of digit. Well, this is not completely correct. The correct identifier would be percentile %p. Using percentile %p, the address is displayed as a hexadecimal value, but the memory address can be displayed in integers as well as octal values. Still, since it is not an entirely correct way, a warning is shown. Int num is equals to 5. Int star p equals to %, num. Printf address using percentile %p is equals to percentile p. Printf address using %d is equals to percentile d. Printf address using %o is equals to percentile o, comma p. The output according to the compiler I'm using is the following. That the first one is a garbage value, and the second one is these values are this is a warning shown when you use percentile d. Warning format percentile d expects argument of type int, but argument 2 has type int star. Some special pointers: the wild pointer, char star alphabet address, uninitialized or wild pointer, char alphabet is equals to a, alphabet address is equals to and percent alphabet. When we defined our character pointer alphabet address, we did not initialize it. Such pointers are known as wild pointers. They store a garbage value, that is memory address of a byte that we don't know is reserved or not. Remember, int digit is equals to 42. We reserved a memory address when we declared it. Suppose we dereference a wild pointer and assign a value to the memory address it is pointing at. This will lead to unexpected behavior, since we will write data at a memory block that may be free or reserved. Null pointer. To make sure that we do not have a wild pointer, we can initialize a pointer with a null value, making it a null pointer. Char star alphabet address is equals to null. It is null value, null pointer. A null pointer points at nothing or at a memory address that users cannot access. Void pointer. A void pointer can be used to point at a variable of any data type. It can be reused to point at any data type we want to. It is declared like this: void star pointer variable name is equals to null. Since they are very general in nature, they are also known as generic pointers. With their flexibility, they cannot be void pointers cannot be dereferenced as any other pointer. Appropriate typecasting is necessary. Similarly, void pointers need to be typecasted for performing arithmetic operations. Void operators are of great use in C. Library functions malloc and calloc, which dynamically allocate return value memory return point void pointers qsort, an inbuilt sorting function in C, has a function as its argument which itself takes void pointers as its argument. Dangling pointer. A dangling pointer points to a memory address which used to hold a variable. Since the address it points at is no longer reserved, using it will lead to unexpected results. Here in this code, main int star ptr is equals to int star bracket malloc size of int star ptr is equals to 1 printf prints 1 free ptr deallocation star ptr is equals to 5 print first id comma star ptr may or may not print 5 though the memory has been deallocated by free ptr. The pointer to integer ptr still points to that unreserved memory address. Pointer arithmetic. We know by now that pointers are not like any other variable. They do not store any value but the address of memory blocks. So it should be quite clear that not all arithmetic operations would be valid with them. Would multiplying or dividing two pointers make sense? Pointers have few but immensely useful valid operations. The first one is you can assign the value of one pointer to another only if they are of the same type, unless they are typecasted or one of them is void star. Int manu is equals to 1. Int star address of manu is equals to and %manu. Int star another address of manu is equals to none. Another address of manu is equals to address of manu. Double star wrong address of manu is equals to address of manu. Invalid star. You can only add or subtract integers to pointers. When you can see it here. When you add an integer, say n to a pointer, you are not actually adding n bytes to the pointer variable. You are actually adding n times the size of the data type of the variable being pointed bytes. The value stored in new address will not be 103, rather 112. Subtraction and comparison of pointers is valid only if both are members of the same array. The subtraction of pointers gives the number of elements separating them. This is a code mentioning the third point. Third point example is this. You can assign or compare a pointer with null. The only exception to the above rules is that the address of the first memory block after the last element of an array follows pointer arithmetic. Pointer and arrays exist together. These valid manipulations of pointers are immensely useful with arrays, which will be discussed in the next section. That's it for this presentation video. This is the basics of pointer concepts. I hope I made it clear. Thank you for spending time for this concept video presentation. Um, Thank you everyone.